AWS Lambda function is one of many popular rapid development solutions available for the cloud. If you have a routine job that runs no longer than 15 minutes, AWS Lambda function would be a good option to implement this. If you're new to this channel, I'm George, and you're on PabloSpot, a space where I show and tell practical examples and sample implementations around DevOps and cloud technology in general. In today's episode, I will look into the basic setup of an AWS Lambda function and then build our way through gaining a better understanding of our options and the how-tos around this particular AWS service. And so, let's start coding. This repository that I have right here already has my baseline Terraform code. With Lambda functions, I usually create another directory in the root of my repository, which I call scripts. And inside this directory are my actual Lambda functions. And my requirements.txt file. As you might have guessed, I'm going to create an AWS Lambda function with Python. And I'm going to start from something really small. Let's assume that I will use the Boto3 and PyOpenSSL as module dependencies for my code. So what I need is declare this inside my requirements.txt file. And then inside my Lambda function script, I am going to set something very basic. So firstly, I am going to import the logging module. And then the OS module. And then I am going to start setting all my logging related code. And then I'm going to define my standard function handler. And inside this handler, I am going to set a very simple logging message. And then, to start setting up the underlying resources to deploy this Lambda function, I will head to my main.tf. And the first resource that I need to create will be responsible in extracting all the module dependencies for my function. So what I will create is a null resource. This resource needs a trigger property which accepts a map. And then inside this map will be a file-based SHA property which will need to point to the requirements.txt file inside my scripts directory. And because this needs to be in SHA-256 format, I will call the file-based 64 SHA-256 function to do this conversion. Also inside this resource block, I need to add a provisioner. These are specific commands or executions that I need to run as part of the infrastructure, and I have the option to set this up locally or remotely. I will run this provisioner locally, and so I will set the label for this provisioner to local exec. And inside this provisioner will be the command property, which will be the command to run pip install for my module dependencies. The -t or target indicates that I want the output of the run to go inside the scripts directory. What this also means is that wherever you run your Terraform command to stand up your Lambda function infrastructure, the pip binary should exist. Otherwise, this part of the code will fail. To summarize what is inside this resource block, whenever there is a change in my requirements.txt file as indicated by a trigger property, the command or commands declared inside the provisioner will be executed. What I need to do next is archive the contents of my scripts directory, and to do this, I will head to my data.tf and define an archive file data reference. I am going to set the type property for this resource to zip, and then I am going to set the source dir and set this to the scripts directory since this is what I want to archive. And then I'm also going to set the output path property with the value set to the name of the output of the archive file. And because I want to make sure that this archive file is created after all my Python dependencies are installed, I will set a depends on property and add a reference to my null resource. The null resource and the archive file data reference I have set up so far are not creating any AWS resources yet. But if I head to my VS Code terminal and export my PF workspace as usual, and initialize my AWS credentials with AWS Vault, and then start running my Terraform commands, although I have not created any AWS resource yet, what you will notice is that there will be files generated inside my repository by this run. So if I switch back to my VS Code Explorer, Notice the zip file in the root of my repository called code.zip right here. And if I expand the scripts directory, the Python module dependencies are also dumped in here, which explains all the different directories right here and some files that's generated by the pip install. I don't want all these files to be included in my baseline code. So what I will do is create a git ignore file inside my scripts directory. And then I am going to set this file to ignore everything by adding asterisk on the first line. And to exclude my Lambda function and my requirements.txt files, I will add a line for each of the file and prepend this with an exclamation point. And then on my root git ignore file, I will add star.zip to exclude the zip file. And now, if I switch to my VS Code terminal and check which files I can stage to Git by running git status, the zip file in the root of my repository and the directories created by pip install are not in the list. So far so good. Now let me head back to my VS Code Explorer. So now, I have set up the basic elements and did some cleanup. What I need to do next is set up the actual AWS Lambda function resource. So let's head back to my main.tf. And then I will add my AWS Lambda function resource. In this resource, I need a function name which is an arbitrary property. I also need the runtime property which I will set to Python 3.9. And then I will set the handler property, which is essentially the name of my Lambda function and the handler method delimited by a dot. I'm also going to add the memory size and set this to 512. Which means I am allocating 512 MB of memory to my Lambda function. For a basic Lambda function, I don't really need much. Hence, I'm setting up the bare minimum capacity for my memory. And then for timeout property, I will set this to 60, which means my Lambda function will time out after 60 seconds. I also need a file name property, which I need to point to the zip file name generated in my archive file. And then I also need to set the source code hash property, which I need to point to the output base 64 hash value of my archive file data reference. And then I also need to add the environment property. And inside this property, I will add variables which accepts a map. If I go back to my Lambda function, which is right here, notice that I'm referencing an environment variable right here for my log level. So I will set the value for this environment variable inside the environment property. So let me head back to my main.tf and then add log level. And set the value for this to info. In order for my Lambda function to run properly, I also need to add the role property. I am going to create an IAM role resource for this, and so at the end of this main.tf, I will create my AWS IAM role resource. This resource needs a name property, which again is arbitrary. And I also need to define the assume role policy property. And I also need to add an inline policy to define the permissions of this Lambda function. For simplicity, I have given this Lambda function permission to create and write into CloudWatch logs. And now that I have an IAM role resource, let me assign this back to my Lambda function IAM role property. And that's it. I'm ready to stand up my Lambda function in AWS. So let's switch back to my VS Code terminal and update my infrastructure. And now that all my Terraform commands have completed successfully, Let's switch to my browser. And then I'll head to my AWS Web Console. And then I will go to Lambda functions. And then I will head to the new Lambda function that I've created right here. And click that. So this page shows the details of my Lambda function. The code tab right here on this page is meant to render my Lambda function. And because I'm using an interpreted language, it is always very helpful to see the plain content of the code, especially when troubleshooting an issue. However, because I have uploaded a very large file, Lambda function is unable to render the code as specified in this message right here. And if I want to test my Lambda function, I can head to this test tab. And because I have a very simple Lambda function, I can just go ahead and click the test button right here. And the run was successful. And if I expand the details of the run right here, and head down to the log output, the message that I have added inside the Lambda function is printed out in the log. And that's all I have for today. On the next episode, we will look into another way of managing the dependencies outside of AWS Lambda function. And this is using AWS Lambda layer. In the meantime, let me know your thoughts in the comments below and send me some likes if you find this useful. And don't forget to hit the subscribe button if you like the content on this channel. Until next time, keep learning and stay safe. See ya.